Hello guys, welcome to my channel. Today's video we are covering with the data analysis with Python series. So in this part of data analysis with Python series, so today's video, the first part we are covering with the NumPy. So NumPy for data analysis. So in this part mainly to explore the arrays, operations and practical examples in this beginner friendly Python tutorial. So let's look into first introduction part. So in this NumPy series, so the NumPy on NumPy for data analysis. So basically, first importance of NumPy in data analysis called as NumPy is the foundation of Python data analysis libraries like Pandas and SciPy. And NumPy arrays are faster and more efficient than Python lists. So it supports vectorized operations, eliminating the need for loops. So in this case, so if you consider as the real world use cases called as mainly scientific computing, finance, and machine learning. So for example, here we'll give the example called as why do data analysts and data scientists love NumPy? So it's the relatable analog is called as mainly imagine working with data as rows and columns of numbers. NumPy is like a supercharged Excel, but faster and smarter. So this is the small introduction about with the NumPy. And regarding the installing with NumPy, installing and importing of NumPy. So let's look into first installing. So installing will call as pip install NumPy. Okay, and enter. Invalid syntax. Pip install NumPy. Why this error is at line 2? Pip install. Okay, it's executing. So requirement already satisfied. So the version number 1.26.4. And how to importing? This one called as like importing the NumPy. So import NumPy as NP. So as NP, why I'm using this called as it's a shortcut. So next time onwards, we'll not write NumPy. We'll use as NP. Let's execute. Okay, so this is done. And verification. So which version we are using? Just already it is showing a 1.26.4. Just for our understanding purpose, how we can check with the NumPy version np dot version underscore NumPy module. NumPy has no attribute or version. Print one more hyphen 1.26.4. So this is the main NumPy as NP called as the alias. It's a convention that makes code to concise and easy to read. So next look into basics of NumPy arrays. Basics of NumPy arrays. So basics is mainly first we'll create the array, like creating a NumPy array from Python list. That is array. So array equals to np dot array of the list. So the Python list will give us 1, 2, 3, 4. Okay. So this is the list. Let's execute this one. This is fine. And we'll print the array. Print arr 1, 2, 3, 4. And print type of arr 1, 2, 3, 4 NumPy nd array. So this is the output of this one. And let's look into key properties of arrays. So key properties are mainly print array dot shape. So sorry, array dot shape. So this is the 4 comma. And if you look into same thing, print array dot d type. So into 32. So in this key properties of arrays is mainly shape and type. Let's look into comparison with Python lists. So Python list allow mixed types, while NumPy arrays enforce a single data type. So example of element-wise operation called as array equals to np dot array 1, 2, 3, 4. This is fine. Let's print the value. Print of array plus 1. See, I'm getting 2, 3, 4, 5. So above it is adding one value. So it adds 1 to each element. Next, we'll write the array creation techniques. So array creation techniques are mainly common methods to create arrays. So np dot zeros 2, 3. So this one, let's execute. Okay, cannot interpret. Okay, one more brace is required here. Yeah. So this is the np dot zeros 2, 3. So that is 2 by 3 array of zeros. So same thing we'll try with np dot ones 3, 2. The array of 1, 1, 1, 1. So 3, 2. That is 3 by 2 array of ones. So np dot arrange. Here I am giving the positions are start position, stop position, and step also. For example, 0 is the start position, stop position, and step. So step is I am giving 2. So if I check now, module NumPy has no attribute arrange. One moment here, AR not this one. So array arrange is step count 2. So 0 to 10, 0, 2, 4, 6, 8. Okay. Next, np dot line space. So for this line space, so we'll give first start position, stop position, and number of points. So start position 0 and stop position 1 and number of points. So that is I'll give 5. See, it is taking from 0 to 1, 5 positions. So 0, 0 0.25, 0 0.5, 0 0.75, and 1. So this is the common methods to create the arrays. Next, let's look into random arrays. So random arrays are mainly np dot random rand 2, 2. So if I give 2, 2 call as 2 by 2 array of random numbers, that is 0 to 1. Okay, so from 0 to 1. Next, np dot random dot rand int 1, 10, will give 3, 3. So here 3, 3 is the random integers in a 3 by 3 array. See, so random integers in a 3 by 3 array 6, 8, 9, 9 to 4, 6 to 8 like this. Okay. Next, so up to this, we have explained as mainly the highlight practical use cases like zeros and ones for initializing the weights and machine learning, arrange and the line space for creating the sequences of data points. Next, look into indexing and slicing. So indexing and slicing, first we'll look into accessing the elements. How we can access the elements. Array equals to np dot array of 10, 20, 30, 40. Okay, first this one. This is fine. Let's look print the value. So print of array position 1. If I give position 1, 20, that is 0, 1, 2, 3. Next to slicing arrays. So how we can do the slicing arrays? So for example, print of array 1, 2, 3. See 20, 30. So 20, 30 is 1, 2, 3, 0, 1, 2. Up to third position, first position to third position. Next, that is elements from index 1 to 2. Next, multi-dimensional indexing. So multi-dimensional indexing is matrix equals to np dot array this one. So here 1 comma 2 comma 3 comma 4 comma 5 comma 6 and close this one, and 7 8 9. So I'm declaring this one as matrix equals to np dot array 1 2 3 4 5 6 7 8 9. This one fine. Something is going. Matrix equals to np dot array. Oh, this entire list we had to close. Okay, so this matrix is fine. Now we have to print the matrix values. So matrix 1 comma 2. So 1 comma 2 first to row 1 and column 2. So row 1 is this one 4 5 6. In row 1 column 2 0 1 2. Okay, next look into print matrix 0. So 1 4 7, that is the first column. Okay. So like visualize the arrays as grids or tables. So use the diagram like this. Next, we look into array operations. So for array operations, element-wise operations. So element-wise operations, array 1 equals to np dot array 1 comma 2 comma 3, and this one also close. Next, array 2 equals to np dot array 4 comma 5 comma 6. Next, print array 1 plus array 2. Sorry, 5 7 9. Okay, so this is like element-wise operations. Next, to look into statistical operations. Statistical operations. So statistical operations are print array 1 sum. I'm getting 6. So 1 plus 2 plus 3, 6. That is sum of elements. Next, look into print array 1 dot mean 2.0. Next, print array 1 max 3. Next, broadcasting. So for broadcasting is mainly array equals to np dot array of 1 comma 2 comma 3. So this is declaring. After then print of array multiplies 2. See the value 2 4 6. Okay. So that is multiplies each element by 2. And next, look into reshaping arrays. So reshaping arrays, array equals to np dot array 1 comma 2 comma 3 comma 4 comma 5 comma 6. Like this is fine. And now we'll do the reshape, like reshape into 2 by 3 matrix. So reshape equals to array dot reshape of 2 comma 3. Okay, so reshape into 2 by 3 matrix. Next, flattening. So flattening is flattened equals to reshaped ravel print flattened 1, 2, 3, 4, 5, 6. Next, look into some examples of practical examples. So practical example. So for this practical example, let's look into simulate the sales data. So sales equals to np dot array 250, 300. I'll give 400, 350, 500. Print total sales dot sum. The total sales is 1800. Similarly, I'll give as like print like average sales. So average sales are sales mean. So average sales 360. Print highest sales max. So highest sales 500 and print lowest sales also will print lowest sales dot min. So lowest sales 250. Okay, so and add a condition. For example, identify the days with sales greater than 300. So print sales greater than 300. Okay, so this is the condition about 300, above 300, 400, 350, and 500. So let's closing scenario. So this is the about with NumPy. So closing scenario is mainly we have covered as in this. So benefits of NumPy in data analysis and key concepts are mainly array creation, indexing, operations, reshaping, and practical use cases. So these are the things we have covered. So thank you for watching. So let's connect in another video, pandas. If you like the content, please like and subscribe. Thank you.